Okay, Anushka, Christine, check.
Yes, I got it. I was trying to use the other formula for some reason.
Which
So A
formula?
is
The
equal to A
exponential.
naught. Yeah, yeah,
But that requires time.
yeah. Yeah, I
We
know.
don't have time here.
I forgot about this.
Okay, chalo. Christine, is it clear?
Yes, sir. Sir, about the lambda, we don't write that down.
We don't write it as in. No.
As in,
Oh, so wait. In this expression, lambda into 10 to the power 6 is your original activity. You know,
okay, okay.
that's why the lambda is not there.
All right.
Next. Okay, this one is tricky. Think what can be done.
Sir, the size of a nucleus is 10 raised to 15, right?
Minus 15.
Minus 15.
So wait, I'll tell you the formula. In the formula, this R naught is 10 to the power minus 15.
Sir, it's 1.2 into 10 raised to
Oh,
minus 15, right?
to be more specific, yes. So do you remember it, Christine, or have you written it somewhere?
No, I remember the 1.2.
It has 1.2 in it. That's it. Put A as 238, and this is paper one, no calculators, approximate.
So is it B 10 to the power minus 14?
Minus 14. Yes, that is right. That's the closest approximation. So tell me these steps. What have you done?
So I just approximated cube root of 238 as around like 8 because 8 cube is
8
216,
cube. Wait,
right?
so take the 64. No, 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 no.
256. 1 minute.
This is beyond 8. This is not 8 because 64 times 8.
Yeah,
This is 512. No,
yeah,
so it's
512.
actually
Okay,
it's
okay.
actually
One second, I
larger.
got confused.
But fine, your even approximation, you got the right answer. Let's check 6. What is the cube root of 6? 216. Huh? So this is close to 6.
Oh wait, I meant 6 and then I wrote 8. I mean, I wrote 6 in one place and then I changed it to 8. 6 is, yeah, sorry.
Fine. So if you put 6 in, the order will be minus 14. Okay, Ahan, Krishnan, check. Ah, right.
Got it, sir.
Try this one.
Is it A?
K is decreasing and Z is increasing. Explain.
So when Z increases, there will be more repulsion, right? And
K
as
increases, more repulsion. Yes.
when kinetic energy decreases, then again it won't be able to make it that far into close to that nucleus, right?
The alpha particles kinetic energy K are fired at proton number Z. Which of the following changes will result in a significant deviation from Rutherford's model? Okay, Ahan, repeat. You are saying kinetic energy should decrease.
Yeah, because it then closest approach won't happen at all, right? It will get deflected off before.
So if it is deflected, uh, no, see this, okay, Ahan, we have done this concept as in the deviation comes only for the alpha particles which are having supremely high kinetic energy so that they can go very close to the nucleus. That's where the deviation comes in. Are you getting the point, Ahmad?
Yeah, but so kinetic energy has to increase.
Then only the deviation will come.
Wow.
Deviation from the Rutherford prediction. Okay, let me show you the MS. All right, so I want you to read out the MS answer. Wait, here, read this out.
With more kinetic energy, alpha particles can overcome the electric potential of the nucleus and get close enough to experience strong nuclear attraction that is responsible for the deviation from Rutherford's model.
Initially, if your kinetic energy is low, the alpha particles will be deflected at quite a large distance away. That is the Rutherford scattering. If you're having intensely high kinetic energy, alpha particles will go very close to the nucleus so that they can experience the attraction also. Okay, wait,
Hmm.
I'll explain. So let me draw a diagram. Watch this, Ahan. Let's say if you have a nucleus of atomic number Z, and then there is an alpha particle. If your Z, okay, if your kinetic energy is small enough, then let's say the deflection is like this, for example, right? But if you're having, let's say, 10 times the kinetic energy, same alpha particle going at 10 times, then it will have a tendency to go much closer to the atom and the deflection will be at a different angle. Because
Okay.
if you go close to the nucleus, it also experiences attraction. Is it?
Yeah,
Uh-huh.
yeah, makes sense.
Okay. Krishni, now tell me which option can we select?
So D.
So, which means value of K is increasing and Z is decreasing. So, how Z is decreasing?
No, so when your Z decreases, then the electric repulsion will also decrease because there will be
Yes,
fewer
exactly.
protons.
Perfect. Lesser Z means fewer protons, lesser repulsion. Hence, option D. Anushka, is it making sense?
Yeah, sir, understood.
Okay. The next question is also on the similar lines. Same experiment. Here are the code. Similar type. Now try this. At least the conclusion should be easy.
So is it B?
So you are saying more than predicted and attractive. So attractive is fine, conclusion is correct. How the intensity is increasing?
Well, from the previous question,
Mhm.
if in this case, if it's deviating from the predicted Coulomb's law, that means that there is the attractive short range force, which means it's probably closer to the nucleus and
Okay.
facing a deviation of a larger angle.
Mhm.
So at 60 degrees, won't there be more alpha particles? Like that
Let,
would.
let me draw a diagram and then explain. So we have a nucleus of atomic number Z, and alpha particle is incoming, and the detector is at an angle of 60 degrees. Let's say D is your detector. These are just the dotted lines. So what is the question here? Wait. So what has been changed? Okay, high energies. So if you increase the energies, then what will happen? That's the question. So now observe. Let's say if we are dealing with a smaller kinetic energy, then what will happen? The particles can follow this path straight away, right? So the alpha particle can reach the detector a lot many. But if your kinetic energy is, let's say, becomes 100 times, then what is supposed to happen, Anishka?
Alright, then it'll deviate more. So
It will deviate
it'll
more or less.
um
It will go
oh well,
very,
technically less.
it will go very close to the nucleus such that it experiences attraction also, which
Yeah.
makes it deviate lesser.
Okay,
Lesser
so then it's
because
A.
of the attraction. And hence, relative intensity is actually lesser, not more. Less than predicted. Is it making sense? So make this
Yeah, so
diagram, all of you. Ahan, is it clear?
So it looks, why would the, hmm, okay, wait. Oh, no, I got it. I got it.
The entire logic stems on the fact that at high energies, alpha particle is able to reach very close to the nucleus where it experiences attraction also.
Right. So when an angle comes into factor, it's always less intensity, right?
Yes, yes. All right, so draw this diagram, write the logic, and then constant.
Hmm.
Team, Anushka.
done, sir.
Wait,
Done, sir.
nice. Moving ahead. Try this. By the way, can all of you hear some background noise at my end, or is it fine?
It's fine, sir.
Okay.
That's fine. Or is it B?
I got B as well.
Yes, B is the answer. No starts being logic.
Well, E is equal to hc by lambda or hf. So the higher the energy, the lower the wavelength. So one is correct because the transition K has a lower energy difference than transition L. And for two, the energy is directly proportional to the frequency.